In programming, we spend a ton of time on numbers and logic, right? But think about what makes software actually feel interactive. It's text. You've got names, messages, search queries, it's everywhere. So how does a computer actually get it? How does it understand what we're typing?
Yeah, it's a really big question when you stop and think about it. When you type something simple like "Hello World" into a program, what's really happening under the hood? Because the computer doesn't see letters like we do. To the machine, it's just, well, it's a very specific kind of data.
And that special tool, it's called a string. We're about to dive into exactly what a Java string is, and, more importantly, the one golden rule you absolutely have to know to really get a handle on it. All right, so first things first, what even is a string? Because in Java, it's way more than just a bunch of letters typed out.
And the key word right there is object. See, a string isn't a simple primitive value like the number 5. Nope, since it's an object, it comes with its own built-in toolkit, all these special abilities and behaviors. And that's exactly what we're going to get into.
Okay, and this brings us to, honestly, the single most important thing you need to understand. If you take away just one thing from our time here, make it this. It's what I call the golden rule, immutability.
So, immutable. What in the world does that mean? It's actually pretty simple. Once a string object is created, it can never, ever be changed. That's it. Its value is locked in, it's permanent. And this photo analogy, it's perfect. Think about it. You can't just draw a mustache on a physical printed photo, right? It's done. But you can scan it, add a funny mustache in Photoshop, and then print a brand new photo. Now you've got two pictures, the original, untouched one, and your new, edited copy. That is exactly how Java strings work.
Okay, let's look at this in some code to make it super clear. On the left, that's what you might expect to happen. You'd think the original string hi just gets changed. But look over on the right, that's what's really going on. When you write s equals hello, Java doesn't touch the original hi at all. Instead, it makes a completely new string, hello, and just points your s variable to that new one. The old hi is just left behind, totally untouched.
So, you're probably thinking, okay, if we can't change them, how do we do anything with them? Well, that's where that built-in toolkit comes in. Strings have all these awesome methods that let us create new, modified copies from the original. Let's check out a few of the most common tools you'll be using all the time.
And this is super important to remember. Every single one of these tools plays by that golden rule. They never change the original string, they just look at it, and then they give you back a brand new one with the changes you asked for.
First up, we've got toUpperCase. This one is so useful for things like standardizing user input. You ask someone for their name and they type it all in lowercase. This is how you fix it.
Let's see it in action. Pretty simple. We've got a string name with the value Java. We call the uppercase method right on it, and we catch the result in a new variable upper name.
And there's our result. The upper name variable is now holding the new string Java. But look, and this is the key, our original name variable is completely unchanged. It's still Java, just like our original photo, totally untouched. Next tool in the box, substring. This is your best friend when you need to pull a smaller piece out of a bigger string. Maybe you need to grab a username from a sentence or something. So in this example, we have hello world. To get just the word world, we use substring. We tell it where to start, that's index 7 where the W is, and where to end, which is index 12. And that basically tells Java, hey, give me a new string with everything from position 7 up to, but not including, position 12. And boom, the result is a brand new string part that just has world in it. And of course, following our golden rule, the original hello world is still there exactly as it was. All right, last one for now, trim. This one is an absolute lifesaver. Seriously, users and, data from files are famous for adding extra invisible spaces at the start or end of text. Trim is the tool that cleans up that mess. Just look at this. Our input string is kind of messy, right? It's got those extra spaces before and after the actual words. To fix it, all we do is call the trim method.
And what we get back is a brand new, perfectly clean string and clean input. No more extra white space. And I'm going to say it again. The original messy string, still there, still unchanged.
Okay, so we've seen these tools one by one, but the real magic happens when you start chaining them together. Let's walk through a super common, real-world task, taking a messy name from a user and formatting it correctly.
Okay, so imagine we get this input, all lowercase with a bunch of spaces. What do? Well, first, we call .trim on it, which gives us back a new, clean string, Jane Doe. Then on that new string, we can use substring and uppercase to grab the J and the D and create more new strings, J and D. Finally, we just stitch all those pieces together to get our final result, Jane Doe. See how that works? It's a chain of operations. The output of one step becomes the input for the next, and the whole time, that original messy input is never, ever touched. That's the power of immutability.
All right, so let's bring it all home. What are the big ideas you really need to walk away with?
Okay, number one, strings are objects, not just simple values. That's why they have that cool toolkit. Number two, and this is the big one, the golden rule. They are immutable. You can't change them. And because of that, number three, every method we used, trim, uppercase, all of them, they don't change the original. They always give you a brand new string back.
And that brings us to a final question, a little food for thought. If every little change creates a whole new string object, what happens when you need to build a really, really long string out of lots of small pieces? You'd be creating tons of temporary objects just to throw them away. I mean, it'll work, but is it efficient? Thinking about the answer to that question, that's really the next step to mastering strings in Java. Hope this helped you out. Thanks for joining me.